Hey guys, Budcat7 here. Okay, it is Friday, May 17th, 2024, and I'd like to thank you for visiting the Stonewall Research 2 channel here on YouTube. Thank you very much, I really do appreciate it. Alright guys, well, I had to name this video what I named it because I don't want a context flag up on there like will happen to certain channels when they mention a certain thing, and I just don't want that happening here because I want to get my point across, and this is one way of accomplishing that. So why don't I start this out by a little joke? Okay, a nice clean one that you can tell your little kids. Okay, it's pretty funny. Okay, my grandfather told me this joke. Okay, I'm passing it on to everybody before we get into this. Alright, why do they only put 239 beans in a can? Because if they added one more, it would be 240. Well, that's a joke that my grandfather told me. That's still funny. I tell everybody that joke and they gotta laugh. But in any case, let's get to this topic here, which is basically about glacial erratics and the Ice Age, which is a theory, by the way. Okay, a theory that can never be a fact, okay, because some things can't be put as facts because nobody was there to witness it and write it down on a piece of paper and say, here's how it is. And that's, of course, that's, secondhand knowledge anyway. But so there's problems with glacial erratics, okay? So, even if you think it was caused by maybe something else, there's always the possibility that human beings might have moved these things, okay? Because I'm not going to show you all the cyclopean stonework from around the planet because you already know about it and you know where it is, like down in Peru and places like Japan and Jordan and Egypt and blah 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 blah. Okay, so you know everything about it and what's possible to move, but of course if you go further back in time, why would people be doing these sorts of things? So when they mention glacial erratics in some contexts, people might say, well, that has to be a glacial erratic because it doesn't look like it was, placed there by human beings. There's no reference to that whatsoever other than that it's somewhere that it shouldn't be. Okay, so of course you naturally have to define what a glacial erratic is before you can even come to that sort of conclusion. But let me just show you what they consider a glacial erratic up here in New York. Okay, it's called the Balance Rock, North Salem Balance Rock here in New York. Okay, so you can see how this stone is sitting on these other pointed stones that are sticking up. And geologists want to tell us that this is a glacial erratic, that, not possible for human beings to do. This thing weighs like 92 tons or something like, a solid piece of granite. So whatever it is, it's incredible, and it seems to be on these pointed stones, but they claim that a glacier gently put it down on these stones there, and that's why it's there. And of course you have another school of thought that thinks that human beings did it, and there's a number of dolmen to be found in the northeastern part of North America. not only New York, but elsewhere. Jimmy the Paleo Mountain Man, and I were up on top of Mount Ephraim, and we saw one ourselves. It's like a flat stone that must have weighed like a ton, with a smaller stone propping it up. Okay, this is what the state of Vermont claimed were mysterious stonework up there on Mount Ephraim. And Jimmy and I were up there. We examined the stone walls up there. And so they're all over the northeastern part of North America, including Canada. I've covered some of the very, very interesting ones from around Canada. And they're smaller than this, but still incredible feats of strength. It was done by people, however they did it, and however they did any of the ones that they know that they that was created by human beings. They know plenty of those. Just incredible feats, in themselves. With these giant slabs of stone, because there's different types of doming, which I'm not going to get into here. But what the whole thing is about is these glacial erratics from around the planet that they want to identify, and we'll go over in a second. But the reason why this whole thing has been prompted is because I was on Facebook, and somebody had posted one of these doming that they found in who knows where, somewhere in the New England area there, and deep in the woods. And these are kind of things that you can see at places like this is Tim McSweeney's page here, which is just amazing what they show over here. And also and then, everybody shares on these pages. Tim McSweeney goes to these other pages that I belong to here. Ancient Stone Mysteries of New England as well. I mean, the things they can see are just amazing on here. And, 90% of this stuff is being put there. Here's one of them right there. Okay, this is a dome in here. And I commented on it, and there's like 19 replies, and I said this was, not a glacial erratic. Some of the people here had chuckles about it, and then of course people are serious about it, and they do believe in the Ice Age and the way that these glaciers deposited these things, etc., etc. And I had commented to them that the Ice Age was a theory, and I guess it triggered this guy where he said, I don't want to have any more to do with this because I feel like my IQ is being lowered. So, I said, well, that you feel like that is the reason why you feel like that is because you've been brainwashed into thinking somehow the Ice Age is a fact, and it's not a fact. Okay, nobody was there to report on it and what it was. Okay, they have to come to it through inference of the data that they collect and how they interpret it. Okay, that's what geology is all about. It's about interpretation. Okay, about layering and all this kind of other stuff. So, and the geology of rocks and strata and blah 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 blah, all this kind of stuff they have to know. It's different specialized fields, etc., etc. So anyway, I triggered this guy here, and I gave my reasoning, and who thought that there was reasons to question the whole Ice Age theory. Okay, and Emmanuel Velikovsky was one of them. Okay, he said that, he thought it was due to some cataclysmic events that just totally devastated the whole planet time and time again. Okay, and, they have all kinds of criticism against Velikovsky. One of them was that, when they did ice core sampling, that they said that, when Velikovsky said that some of these cataclysmic events happened, it was like worldwide, and they did these ice core samples, and it didn't show that, in their opinion, if that they're reading the ice core samples right. Something happened, but not on the scale that Velikovsky said. But maybe the severity of these things were more localized. Who's to say that? So in any case, Velikovsky was one of them that sort of was not in favor of the Ice Age theory, and he gave his reasons why. And William Corliss was another one. If you want to, go with a more credible candidate for anyone who might have anything that, to question about the Ice Age, it would be this fellow, William Corliss. Okay, so if you don't know about William Corliss, he worked for the government for a while, and he wrote some educational books for the government, for different departments. And then after he sort of retired, or in between all that stuff, he started writing these books about all these anomalous things, all these different areas of science, whether it be biology, geology, astronomy, etc., because he's a well-read and well-studied scientist himself. So he's a physicist from Rensselaer Polytechnic Institute. He's a Bachelor of Science in Physics and a Master of Science in University of Colorado. So not a PhD, but Master of Science and a Bachelor of Science in Physics is pretty good. And, just a well-educated scientist, I guess, who got a job for the government. But let's read a little bit about what this dumb guy had to say, because that's, like this fellow who got all triggered by what I said, must have, thought that, the Ice Age is a fact, and it isn't. So let me just read you a little bit about this dummy William Corliss, because I'm itching to do some reviews of some of his books. I was even thinking about starting a channel just dedicated to reviewing William Corliss books, because it's fascinating to me, some of the stuff that I've read so far, from borrowed books from friends, etc. So, I just think that the guy has something to say about these things, and he has all the credentials to sort of comment on these things. So let me read you a little bit about William Corliss here before we get into it. It has everything to do with it, really, because I sort of go with these fellows, whether it be Velikovsky or Corliss here, and there's some questions about these theories, and things don't make sense on certain levels and aspects of what the theories have come up with, because they have to be explained. It's a very detailed science. It's not something to be explained in 5 minutes or even an hour or whatever. So let me just read to you about Corliss, because he's an interesting character in opinion of Wikipedia here, or whoever's writing for Wikipedia here. But the article sort of focuses on his main works, his personal works, not the government works, but you have to look at that too. Alright, so William Roger Corliss was an American physicist and writer who is known for his interest in collecting data regarding anomalous phenomena, including cryptozoology, out-of-place artifacts, and unidentified flying objects. Corliss was Charles Fort's most direct successor. Arthur C. Clarke described Corliss as Fort's latter-day and much more scientific successor. And that's really the key to it. It's, although Corliss went into these things like UFOs and out-of-place artifacts and stuff, he talks about a lot of general science as well, and gave it a sort of classification of his own. So anyway, let me read on. Starting in 1974, Corliss published a number of works in the Sourcebook project. Each volume was devoted to a scientific field, archaeology, astronomy, geology, etc., and featured articles culled almost exclusively from scientific journals. Corliss was inspired by Charles Fort, who decades earlier also collected reports of unusual phenomena. Many of the articles in Corliss' works were earlier mentioned in Charles Fort's works. Unlike Fort, known for his idiosyncratic writing style, Corliss initially offered little in the way of his own opinions or editorial comments, preferring to let the articles speak for themselves. Corliss quoted all relevant parts of articles, often reprinting entire articles or stories, including illustrations. In some of his later sourcebook efforts, such as the mid-1990s biological anomaly series, Corliss added his evaluation of both the reliability of the claims and their ranking as anomalies. Well-documented reports from credible sources are ranked as a 1, while entirely unsubstantiated reports are rated as a 4, with 2 or 3 representing intermediate reports. Similarly, Corliss's uses a rating of 1 for anomalies that cannot be explained by existing scientific theories, while a 4 describes phenomena that are unusual but do not challenge scientific theories. Corliss wrote many other books and articles, notably including 13 educational books about astronomy, outer space, and space travel for NASA, and a similar number for the Atomic Energy Commission and the National Science Foundation. So, let me get this straight. You're writing educational books about these disciplines, okay, and these studies. So, that would mean you would have to have basically a full understanding of all these various types of sciences before you start writing educational books on them, I would imagine. Alright, so that means a full understanding of astronomy, outer space, and space travel for NASA. Atomic Energy Commission, well, that would assume anything to do with atomic physics. And the National Science Foundation, I guess science in general. Okay, so I guess the government considered him good enough to write for all these different departments, don't you think? But so anyway, he went on to write these books. Alright, so let me read the rest of the article here for it's not long. In his book, Unexplained, Jerome Clark describes Corliss as essentially conservative in outlook. He explains Corliss is more interested in unusual weather, ball lightning, geophysical oddities, extraordinary mirages, and the like. In short, anomalies that, while important in their own right, are far less likely to outrage mainstream scientists than those delighted for it, such as UFOs, monstrous creatures, or other sorts of extraordinary events and entities. Author C. Clark said, unlike Fort, Corliss selected his material almost exclusively from scientific journals like Nature and Science, not newspapers, so it has already been subjected to a filtering process which would have removed most hoaxes and reports from obvious cranks. Nevertheless, there is much that is quite baffling in some of these reports from highly reputable sources. The meteorologist Charles A. Doswell has praised the research of Corliss, stating his documentation of anomalies was intriguing. However, the geologist, that's the one that's really gonna get him, okay, because other sciences are more precise, like mathematics and physics and et cetera, okay? Geology is not that precise, okay? It's a matter of interpretation of events that went on in the past through the stratigraphy and ice core sampling and sea core sampling and all this kind of stuff, a lot of stuff about that can't be explained. But in any case, let's go on. I want to get through this. Okay, so however, the geologist Henry Fall has criticized Corliss. In a review for a handbook of unusual natural phenomena, Fall noted Corliss is particularly prone to classifying things as unexplained even when a good explanation is available, grossly incomplete, naively uncritical, supplied with inaccurate sketches, many of them fictitious like the illustrations in old novels, and lacking an author index. It is no handbook at all. Instead of giving new access to genuinely mysterious observations, it only buries a few of them in a clutter of confused esoterica. In a review for a book that documented astronomical anomalies, the astronomer Joseph Vaverka wrote that Corliss had shown negligence of the scientific literature for more than a decade and made incorrect statements. However, Richard Baum wrote a mostly positive review, stating that it was an objective work, and his reviews are concise and well referenced. And if on occasion his examples are questionable, we do at least have the benefit of the bibliographies, which will be useful to historians. So, contradicting the other guy, there is references, etc. Just whatever, straw man, fallacious reasoning of any variety. Science journalist Jeremy Cherfus in The New Scientist suggested that Corliss' book Incredible Life had an agenda to challenge evolutionary theory, as he believed that natural selection fails to explain biological mysteries. Science writer John Gribben positively reviewed Corliss' book Unknown Earth in The New Scientist, stating it was a delightful mixture of established science and the lunatic fringe. Where else can you get such entertainment at so little cost? So, sort of backhanded compliment there, okay? But, of course this guy is going to be critical of anybody who challenges the Ice Age theory, the geologist that challenged it, and the astronomer too. Or what do they know about it? What NASA has been, well, he worked for NASA. He knew everything about this, okay? And he had questions about it since he knew it inside and out and had to write educational books about it, okay? So he had questions about some things, but that's a big no-no, from one scientist, to another. Oh, that's not your specialty, or you're not a PhD, or whatever reasoning, it doesn't matter. Okay, it's like 90% of the major archaeological discoveries were all made by amateurs. No professionals made the major archaeological finds of the last 200 years. It's all done by amateurs, all the major finds, okay, that we know about. Any new ones by LiDAR or otherwise, okay, well, we found those in that way, okay, but these people went out in the jungles and shit like that and did it. But in any case, this guy Corliss was a pretty smart guy, and he wrote all his books because he had all these questions about these things. And though he had questions, he gave no comment about it. He didn't offer his opinion about it or anything. He just said, hey, look at this, okay? You make of it what you want, okay? It's the sort of thing like C.W. Saram did in his book, The First American. You have to be like that in order to get your books. Well, of course, now it's different, but back then it was something else, even 20 or 30 years ago. You had this sort of etiquette with publishing, your books and stuff. That's why you have to have a legal publisher, you have to have a lawyer help you with these things and all that sort of stuff that has to go with the writing professions, etc. So Corliss was a bit of a genius in his own right in sort of offering up just a vast amount of material. He goes through all the books over down the bottom here and his bibliography here. Just here's some of the books he wrote for the government: Propulsion Systems for Spaceflight, Radioisotopic Power Generation, Space Probes and Planetary Exploration, Scientific Satellites, Mysteries of the Universe, Teleoperator Controls, Mysteries Beneath the Sea, Human Factors Applications in Teleoperator Design and Operation. Okay, so whatever, just you can read it all yourself if you want to go to the page and look at it. Okay, Wind Tunnels of NASA, okay, so just a brilliant guy, I'm sure. And reading some of his material, it certainly seems that way. It's just not his, he's just reporting on the facts, more or less. Okay, and he questioned the Ice Age on certain grounds. Okay, and here you can see my friend Harry Hubbard. Okay, the Lost Tomb of Alexander. This is Harry Hubbard's channel. Okay, of Illinois cave fame and the artifacts there and all sorts of things. Harry covers ancient coins and counterfeiting and comparisons, and comparative analysis of modern, nonfiction, textbook type stuff with older textbook type stuff. It's just fascinating, some of the stuff. And here he has this video here on his channel, which you should go and watch. The Religion of Geology. I'll put a link to it in the description. And global warming, climate change. So look, these are the things that Harry talks about in this video here. And of course, he was the flag for the contacts. That's why I'm saying I named the video what I named it, because I just don't want any context things down there plaguing my video here, because I don't need their explanation. You don't have your own explanation. We'll tell you what the explanation is and let everybody know, just in case you're saying something wrong. See? And the AI right now is still under human control, but hey, when the AI starts thinking about itself, all this stuff about us could care less about, right? Keep doing that AI stuff. So here's Harry Hubbard actually reading some of Corliss's work here on his channel. You could read this little thing here while I'm talking here. Okay, some of the things that Corliss questioned about it, okay? And I thought about it quite a bit myself, and how things work in this world that just would not make any sense for glaciation occur to such an extent that they say it occurred at. It's just like impossible. But here people like Louis Agassiz, which Corliss mentions in his writings there. Okay, so Louis Agassiz, who came up with the theory, okay, of the Ice Age, okay, so you can read it right in here yourself, that it's not a fact, it's a theory, and that's all it's ever been. It is not a fact, it's not proven at all, and never can be, and they know it. This theory will never be a fact. No one was there to witness it. It's all but like forensic evidence, but like I tell a story sometime on my other channel, okay, which I did a video about the Ice Age as well. I liked Harry so much, I'm going to do one of my own on my own channel, which I did. Okay, and I talk about this principle here. Okay, so so what do they say about glaciation and how it occurs? And I'm showing people with snow shovels here because this is an experiment that you can do all by yourself. Okay, and what is glaciation about? the flow of glaciers. What is the flow of glaciers is best described as this. Okay, glaciers flow erratically due to their irregular movement pattern. Glaciers are large masses of ice that are constantly moving under their own weight and the force of gravity, flowing downslope in the direction of the slope on which they rest. The movement of a glacier is best described by terms such as internal deformation, basal slip, and pseudoplastic flow. Okay, so whatever kind of cockamamie terms they want to make up for it, the whole ice sheet had to go up and over mountains and all this kind of stuff, which Corliss question is, how's it going to go up and over mountains? Okay, so it's easy to understand what Corliss is saying because I understood it in my own evaluation of how things work on a level of physics. Okay, so I'm a college graduate. I don't want to go over it again, and Dean's List and Honors List and degree in computer engineering. So in any case, I studied many things as an autodidact as well, but nevertheless, okay, so the thing is that, okay, so it's glaciation, the flow of glaciation happens because of the force of gravity. So it flows down a slope, right, a gradient that would be on an angle towards the flat ground, right? So once it reaches the flat ground, right, then it's going to spread over the flat ground in all different erratic directions, like they say. Okay, so at some point, the weight of the ice it's pushing on the ground is going to exceed the weight and force of the whatever snow is pushing down on the slope that it's moving on through the force of gravity. Okay, so it's going to exceed that at some point where you can't push it, and it's easy to demonstrate, okay, with a little experiment of your own in your own driveway, especially if you live in a northern climate. I can't say anything about a southern climate people, but if you're anywhere that it snows heavily, and sometimes it's very heavy snow, okay, when you use the type of shovel where you push snow, which is like all these videos about fancy fangled shovels that do the job real quick and everything else like that, because it becomes difficult. If you notice, and you see people in these videos struggling to push the snow with these push shovels and all kind of stuff. Okay, so as you push the snow and it builds up in the shovel as you're pushing it, and all the snow in front of it starts to build up, at some point you can't push it anymore because the snow has built up in front of it to such a degree that it exceeds the amount of force that you can apply. You see, you're applying, and this is on a level gradient. It's not with the force of the downward flow, but similar in force. Okay, so with all your force, you could do that and be drawn to a dead stop because all the snow, all that heavy, wet snow in front of you, when it builds up, it stops you from pushing anymore. Okay, the weight of the snow in the front exceeds the weight of the snow that's in the shovel that's pushing down on it, right? So the slope of a valley, of a ravine, of a crevice, of between mountain ranges, etc., can only be so high. Okay, let's say it's 10,000 feet, all right? Okay, a couple of miles up, right? So, and it's pushing all over the earth on flat areas where the ice would miles of ice would far exceed the amount of force and pressure that whatever amount of ice was left on the downward slope applying through gravity. You see? So it's impossible that glaciers spread all over the globe down to the equator. That's what Agassiz said. Because of this drift that they find down there or whatever. Couldn't be anything else that might cause it, like Velikovsky says, or Corliss challenges, okay? But, at the equator, because of the way that the Earth is, okay, the average temperature at the equator is 31 Celsius or 88 degrees Fahrenheit. Okay, all year round. The equator temperature remains relatively constant throughout the year because it receives consistent sunlight due to the Earth's tilt. The equator's wet equatorial climate is characterized by high temperatures, heavy cloud cover, high humidity, and little annual temperature variation. Okay, so glaciers down at the equator? I don't think so. Okay, that's pretty funny. So, nah. And that's what, Corliss was saying in his books there. It's just like, not happening. Okay? It doesn't matter what Louis Agassiz, the drunken Swiss American there, up on, vacation down by the little village of Bex by the lake there, where he met his friends about their recently announced glacial theories that startled the scientific world. Well, what are these glacial theories? Well, the glacial theories are these glacial erratics. How'd they get there? There's only one possible way. By huge, mile high, glaciers, depositing in there somehow. Okay, one way or another. Okay, so that's, what you got about one way or another. But, like Corliss mentioned and Harry Hubbard, there's all this stuff at the bottom. There's all this rubble that was slowly grinding everything up and scraping everything and carving everything, and everything would have been ground to dust, against each other, like similarly of putting, and also rounded as well. So, and not these, jagged edge type ones and whatnot. So, any case, what does it say? In 1837, Agassiz proposed that the Earth had been subjected to a past ice age. He presented the theory to the Helvetic Society that ancient glaciers flowed outward from the Alps, and even larger glaciers have covered the plains and mountains of Europe, Asia, North America, and smothered the entire northern hemisphere in a prolonged ice age, not one in which, woolly mammoths become flash frozen with jungle material in their mouth somewhere in Siberia. How'd that happen? They're woolly mammoths. Not old enough for that, but in any case, I don't know, but look, so this is a theory, folks. It says it right here. He presented a theory to the Helvetic Society, and they said, yay, I like that one. And that's how it happens. This whole, I said to this guy, I said, they vote on it, and they like the best theory, and that's how scientific theories come around. Oh, no, it doesn't. It's all subject to critical analysis, and blah, 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 blah. I said, I don't care what they say. Peer review is equivalent to voting, okay? I like it. I don't like it. That's it. You know what I mean? I agree with it, I don't agree with it. So there's more agrees, well, then that's what happens. So that's a vote. So you call it whatever you want. And you can call theories whatever you want. They're just made up fantasy stories. No, they're not. They're critical analysis and blah, blah. You know, I had to listen to this on Facebook there just to hear it. I said, buddy, it's a theory. And as long as it's a theory, it's open to interpretation. Tough noogies. That's all there is to it, okay? And certain people, like William Corliss, challenge that, okay? He said, well, what about this and what about that? It's a little hard to explain. Now, isn't it, if this is what happened? So, here it is on Harry Hubbard's again. Go and watch this video there, Religion of Geology, Global Warming, Climate Change. So, just follow along and you can see what he covers, what Velikovsky said about it as well. Okay, so he had questions about it too. Velikovsky was Einstein's friend. Einstein didn't think his ideas were crazy. He thought they were good. Thought his arguments were good. But shh, don't tell anybody. They were best friends. They opened the yeshiva in Israel there, the university there together, because they were best friends. Okay? And Einstein didn't think his ideas were crazy. He thought they were good. But don't tell anybody. And Thunderbolt's project agrees with Velikovsky. They don't agree with Einstein, but that's the truth of it anyway. But so anyway, what are these glacial erratic things that they're referring to as convinced Agassiz there to come up with his cockamamie theory? All right, that doesn't make any sense. You've got to check with physicists about it to figure out what these materials are doing to each other, what's really possibly happening, and pushing up and over mountain ranges and stuff like that ain't going to happen. The weight of it, you know, from the little force of gravity from where, you know, hundreds and hundreds of miles away, of glaciers pushing down on it somehow or whatever, it just doesn't make any sense. Okay, that's my estimate on it, based on shoveling snow. It's just as simple as that. Okay, that's why all these people have these fancy shovels, to show you how easy it is, and better the way of doing it with these fancy shovels other than that old way, because it was murder. Okay, once the force of all that snow built up in front of the push shovel there, you know, it's just forget about it. And you know, all these push shovels are for light snow anyway. They're not really for heavy snow. You know, heavy snow you got to dig, or you know, cut through with with the snow blower. You know, so anyway, let's see what these things they say are glacial erratics. Just like, you know, they say, you know, this thing is a glacial erratic, and it's not. It's a test of strength. I go over it. I talk about that, and you know, on Facebook too. How dare you talk about tests of strength? Whoever you want to think did it. All right. What would the reason be for these things? You know, oh, it's religious or whatever it is. Well, I read it so many times in the Myths of the Giants, and I did a series of videos on my other channel, my Stonewall Research channel, the Myths of Giants. Okay. And always contests of strength with giant stones. Just over and over again in various people's mythologies around Europe and in the United States among the native peoples. Okay, these people from the ancient past always play, giant people from the ancient past always playing with stones and tests of strength over and over again. Alright, so tests of strength. What else would it be? Okay, in these other sort of dolmen from around the world, these tabletop dolmen that they talk about, and you've seen many of them in Europe and Korea, believe it or not. They find like identical ones there. How'd that happen? You know, from the Neolithic period? News travels fast, I guess. So, and you know, and people with weird skull types too, dug up in all these areas. No, that doesn't matter. And they're a little larger, just more robust. like chock full of nuts. But in any case, so let's see some of these dolmen here. They're glacial erratics that they talk about, which couldn't have possibly have happened. So this is, first of all, you got to believe that the Ice Age theory is all good, okay, and it's not. So if it's no good, then there can't possibly be these glacial erratics. But just to entertain ourselves and entertain me, you know, we can read about it a little bit, all right, and see what kind of cockamamie stuff they're talking about. Because to me, it seems pretty cockamamie. I hate to say it. All right, so in any case, a glacial erratic is a glacially deposited rock differing from the type of rock native to the area in which it rests. So this is what gave them rise to these geological theories when geology was in its nascency. You're talking about the early 1800s to almost mid 1800s, where they came up with these theories. Of course, many theories from the 1800s we have abandoned already because of whatever scientific discoveries proved them wrong or whatever. So, you know, is there evidence to prove these theories wrong? Well, of course there is. But you never hear about it and never going to hear about it because they want you to think that the Ice Age is a fact when it's a theory. And that's all it's ever going to be. All right, so is a glacially deposited rock differing from the type of rock native to the area in which it rests? Erratics, which take their name from the Latin word errare, to wander, are carried by glacial ice, often over distances of hundreds of kilometers. Erratics can range in size from pebbles to large boulders, such as Big Rock in Alberta, 16,500 tons, or 18,200 short tons in Alberta. I guess, measurements of the realm there, big old rocks there. Okay, geologists identify erratics by studying the rocks surrounding the position of the erratic and the composition of the erratic itself. Erratics are significant because they can be transported by glaciers and are thereby one of a series of indicators which mark the path of prehistoric glacier movement. Their lithographic origin can be traced to the parent bedrock, allowing for confirmation of the ice flow route. They can be transported by ice rafting, which allows quantification of the extent of glacial flooding resulting from ice dam failures which release the water stored in proglacial lakes such as Lake Missoula. Erratics released by ice rafts that were stranded and subsequently melted, dropping their load, allow the characterization of the high water marks for transient floods in areas like temporary Lake Lewis. Erratics dropped by icebergs melting in the ocean can be used to track Antarctic and Arctic region glacial movements for periods prior to record retention. Also known as drop stones, these can be correlated with ocean temperatures and levels to better understand and calibrate models of the global climate. So see, these has to do with climate change, okay? So some relationship that they're drawing there, probably erroneously, but they're still going to draw it anyway because there's no explanation for these things other than glaciers doing it. So, formation of erratics. The term erratic is commonly used to refer to erratic blocks, which geologist Archibald Geikie describes as large masses of rock, often as big as a house, that have been transported by glacier ice and have been lodged in a prominent position in the glacier valleys or have been scattered over hills and plains. An examination of their mineralogical character leads the identification of their sources. In geology, an erratic is material moved by geologic forces from one location to another, usually by a glacier. Okay, so it's lodged in a prominent position in the glacier valleys. Okay, large masses of rock, often as big as a house. Okay, so where have large rocks the size of a house been moved elsewhere around the planet here by human beings. Okay, so Baalbek, Saskai Wyman, okay, Japanese Imperial Palace, and all the other Cyclopean sites of megalithic stuff and Cyclopean stuff around the planet that were done by human beings and other things, right? Moved by human beings, but not these things, I guess, right? Because further back in time, they weren't fascinated by stone or rock or anything, right? Nah. Not like these cockamamie pages are all about over here. No. We weren't creating things with rocks and stones and all that sort of stuff. Nah. So, the whole idea is ridiculous, if you know what we know, okay? And of course, like as I said, look, my research goes through all the sort of large humanoids of the past that were obviously found and dug up and admitted to when they come to people like the Adena and the Bell Beaker cultures of Europe. There's no other. I read it to you right from Wikipedia, all about them, right? Which I described their skeletal structure, their skeletal anatomy, and it's not human. All right? They existed with no explanation where they come from, or any other sort of predecessors or anything like that. All right? So, look, okay, so, they say these things are glacial erratics. So, how's it all happening? How's these glacial erratics all happening? Okay. Erratics are formed by glacial ice erosion resulting from the movement of ice. Glaciers erode by multiple processes including abrasion, scouring, debris in the basal ice scrapes along the bed, polishing and gouging the underlying rocks similar to sandpaper on wood, producing smaller glacial till. Plucking, pieces of bedrock are cracked off by glaciers, producing larger erratics. Ice thrusting, the glacier freezes to its bed, moving large sheets of frozen sediment at its base along with it. Glacially induced spalling, layers of rock are spalled off the rocks below the glacier during ice lens formation. This provides smaller debris, which is ground into the glacial basal material to become till. Evidence supports another possibility for the creation of erratics as well. Okay, so you got more. Rock avalanches onto the upper surface of the glacier, supraglacial. Rock avalanche superglacial transport occurs when the glacier undercuts a rock face, which fails by avalanche onto the upper surface of the glacier. The characteristics of rock avalanche superglacial transport includes monolithological composition. A cluster of boulders or similar composition are frequently found in close proximity. Commingling of the multiple lithologies normally present throughout the glaciated basin has not occurred. Angularity. The superglacial transported rocks tend to be rough and irregular with no sign of subglacial abrasion. The size of the boulders are roughly planar, suggesting that some surfaces may be original fracture planes. Great size. The distribution of the boulders tends to be skewed toward larger boulders than those produced subglacially. Superficial positioning of the boulders. The boulders are positioned on the surface of glacial deposits, as opposed to partially or totally buried. Restricted aerial extents. of the boulder fields tend to have limited aerial extent. The boulders cluster together, consistent with the boulders landing on the surface of the glacier and subsequently deposited on top of the glacial drift. Orientations: the boulders may be close enough that original fracture planes can be matched. Locations of the boulder trains: the boulders appear in rows, trains, or clusters along the lateral moraines as opposed to being located on the terminal moraine or in the general glacial field. Glacier-borne erratic. Erratics provide an important tool in characterizing directions of glacier flows, which are routinely reconstructed used on a combination of moraines, eskers, drumlins, meltwater channels, and similar data. Erratic distributions and glacial till properties allow for identification of the source rock from which they derive, which confirms the flow direction, particularly when erratic source outcrop is unique to a limited locality. Erratic materials may be transported by multiple glacier flows prior to their deposition, which can complicate the reconstruction of the glacial flow. Ice-rafted erratic. Glacial ice entrains debris of varying sizes of small particles to extreme large masses of rock. This debris is transported to the coast by glacier ice and released during the production, drift, and melting of icebergs. The rate of debris released by ice depends on the size of the ice mass in which it is carried, as well as the temperature of the ocean through which the ice flow passes. Sediments from the late Pleistocene period lying on the floor of the North Atlantic show a series of layers referred to Heinrich layers, which contain ice-rafted debris. They were formed between 14,000 and 70,000 years before the present. The deposited debris can be tracked back to the origin by both the nature of the materials released and the continuous path of debris release. Some paths extend more than 3,000 kilometers, 1,900 miles distant from the point at which the ice flows originally broke free. The location and altitude of ice-rafted boulders relative to the modern landscape has been used to identify the highest level of water in proglacial lakes, Lake Musselshell in central Montana, and temporary lakes, Lake Lewis in Washington State. Ice-rafting debris is deposited when the iceberg strands on the shore and subsequent melts or drops out of the ice flow as it melts. Hence, all erratic deposits are deposited below the actual high water level of the lake. However, the measured altitude of ice-rafted debris can be used to estimate the lake surface elevation. This is accomplished by recognizing that on a freshwater lake, the iceberg floats until the volume of its ice-rafted debris exceeds 5% of the volume of the iceberg. Therefore, a correlation between the iceberg size and the boulder size can be established. For example, a 1.5 meter diameter 5-foot boulder can be carried by a 3 meter high 10-foot iceberg and can be found stranded at higher elevations than a 2 meter 7-foot boulder, which requires a 4 meter high iceberg. Okay, so they must have done some experiments with this, I would imagine, with ice and rocks or something like that, to prove these points. There's a problem with that, though, and I can't go into it here now. It's about the relative size of things and gravity, etc. So, and how that works as things progress from smaller to bigger. There's something to be said about that. So, let's see what they say about large erratics. Large erratics consisting of slabs of bedrock that have been lifted and transported by glacier ice to subsequently be stranded above thin glacial or fluvial glacial deposits are referred to as glacial flows, rafts, or erratic megablocks. Erratic megablocks have typical length to thickness ratios on the order of 100:1. These megablocks may be found partially exposed or completely buried by till and are clearly alactonous. since they overlaid glacial till. Megablocks can be so large that they are mistaken for bedrock. What does this mean anyway? An allotonnous block is a large block of rock which has been moved from its original site of formation, usually by low-angle thrust faulting. The term is derived from Greek, meaning other, sthon, meaning earth. For other possible mechanisms, see abduction. Okay, so that's what they claim these mega blocks are, because they're on top of the glacial till. That's what it has to mean. Megablocks can be so large that they are mistaken for bedrock until underlying glacial or fluvial sediments are identified by drilling or excavation. Such erratic megablocks greater than 1 square kilometer, 250 acres in area, and 30 meters, 98 feet in thickness, can be found on the Canadian prairies, Poland, England, Denmark, and Sweden. One erratic megablock located in Saskatchewan is 30 by 38 kilometers. 19 miles by 24 miles, and up to 100 meters or 330 feet thick. Their sources can be identified by locating the bedrock from which they are separated. Several rafts from Poland and Alberta were determined to have been transported over 300 kilometers, 190 miles from their source. Non-glacial erratics. In geology, an erratic is any material which is not native to the immediate locale but has been transported from elsewhere. The most common examples of erratics associated with glacial transport, either by direct glacier-borne transport or by ice rafting. However, other erratics have been identified as the result of kelp holdfasts, which have been documented to transport rocks up to 40 centimeters, 16 inches in diameter, rock entangled in the roots of drifting logs, and even transport of stones accumulated in the stomachs of pinnipeds during foraging. What are pinnipeds? Seals. Okay, why don't they just say seals? Okay, and the rocks transported by them, how big are they? Okay, not big. So during the 18th century, here's the reason for the theories that led to the Ice Age theory. During the 18th century, erratics were deemed a major geological paradox. Geologists identify erratics by studying the rock surrounding the position of the erratic and the rock of the erratic itself. Erratics were once considered evidence of a biblical flood, but in the 19th century, scientists gradually came to accept that erratics pointed to an ice age in Earth's past. Among others, the Swiss politician, jurist, and theologian Bernhard Friedrich Corny saw glaciers as a possible solution as early as 1788. However, the idea of ice ages and glaciation as a geological force took a while to be accepted. Ignaz Venetz, 1780 to 1859, a Swiss engineer, naturalist, and glaciologist, was one of the first scientists to recognize glaciers as a major force in shaping the Earth. In the 19th century, many scientists came to favor erratics as evidence for the end of the last glacial maximum, ice age 10,000 years ago, rather than a flood. Geologists have suggested that landslides or rock falls initially dropped the rocks on top of the glacial ice. The glaciers continued to move, carrying the rocks with them. When the ice melted, the erratics were left in their present location. So a different force, landslides, did these things, and when the glaciers retreated, they left these things. So Charles Lyell's Principles of Geology provided an early description of the erratic, which is consistent with the modern understanding. Louis Agassiz was the first to scientifically propose that the Earth had been subject to a past ice age. In the same year, he was elected a foreign member of the Royal Swedish Academy of Sciences. Prior to this proposal, Goethe, de Saussure, Venetz, Jean de Charpentier, Carl Friedrich Schimper, and others had made the glaciers of the Alps the subjects of special study, and Goethe and Charpentier, as well as Schimper, had even arrived at the conclusion that the erratic blocks of alpine rock scattered over the slopes and summits of the Jura Mountains had been moved there by glaciers. Charles Darwin published extensively on geological phenomena, including the distribution of erratic boulders. In his accounts written during the voyage of the HMS Beagle, Darwin observed a number of large erratic boulders of notable size south of the Strait of Magellan, Tierra del Fuego, and attributed them to ice rafting from Antarctica. Recent research suggests that they are more likely the result of glacial ice flows carrying the boulders to their current locations. Okay, so they're going to give all these examples here, and we're going to see them, I guess. These pictures of all these things here, and here's one that Corliss would probably, because this one's been rounded, it must have been on the bottom layer and rounded somehow by these mile-thick glaciers that somehow pushed over flat plains and over mountains and stuff like that. You know, because they were mile high or 2 miles high, sure, they're going to push over the mountains, but the mountains still seem to be there. It didn't level it all flat. So how could that possibly happen? That's how to get up the mountain too. That's another thing about what Corliss says. And according to him, that anything under the ice that would have been there, rocks, whatever, pulverized into dust. There would be no big ones left. And if you look at modern day glaciers, it's a kind of slushy sludge that gets pushed out there. There's some little bit of bigger sized rocks, but no huge boulders getting pushed out of there anywhere along any current glaciers that are formed around the earth. So yeah, okay, so you see these rocks and everything, so you say glaciers must have moved them. So in places where there's glaciers now, well, are they moving big rocks now? Well, no, they're not. See, that's the whole thing. All they see is this like rocky ground up sludge, because that's what happens. It gets pulverized. Okay, just when things get pulverized, like unfortunately what was left of the Twin Towers when it collapsed and everything, these giant buildings collapsed into their own footsteps, reduced into dust, complete dust. Okay, and so these are the kind of things that Velikovsky's talking about. And, you know, worlds in collision, and Corliss is talking about how different physical properties of things can't possibly make these things happen. Okay, so they're saying these things were just dropped where they were from above. When it came from above, the ice melted and they deposited these things where they were, nice soft landing right where they were, and thinking as these things retreated and melted or whatever, it is just pulling away. Ice ages take long periods of time, and unless it was extremely rapid melting, there's going to be a whole process of this shrinking going on. Okay, and you know, this is just a boulder field here they're showing here, and you know, a rock coming from somewhere else, deposited somewhere. Okay. Here's basalt and granite in the background here. He's in the middle of the plains here. Just a couple of rocks deposited there, according to them, nice and easy. Okay, what not understood by me is that if you have this gradual pulling away, even if there is till below it, all right, of these giant rocks and boulders, okay, if you have gradual pulling away, well, at some point there's going to be evidence of this drag mark going along the very surface to its final resting place. How could it be any other way? Okay, if it's receding and it's moving as it recedes, and it's on the bottom. Okay, so it's obviously something this large and weighty and everything is going to dig out some sort of channel to where it finally rests. It's not going to come down like it comes from an hourglass and drop nice and comfy onto a nice soft bed there. If that's what they're saying, that's impossible. If it's receding gradually over great lengths of time, there's going to be these gouges out of the earth or whatever to where its final resting place is going to be. Okay? That's if you believe in this such nonsense. Okay? I already proved to you, you can prove to yourself again. Pushing snow. At some point, the snow in the front exceeds the force that's pushing it from the back. It just does, because it weighs entirely too much greater than the force that's pushing it down. That's when it spreads out to the sides, but it can only spread out to the sides so much, because the same problem exists. Okay, you could do this yourself, okay? If you set up some sort of angled gradient, okay, with a board or something like that, and make a channel in it, okay? And then continue the channel out on the ground area. You can even round it out by the bottom there. And just start pushing, make it nice and lengthy, and just start pushing blocks of wood down it. You're telling me as time goes on, as you're pushing and pushing, it's not going to exceed your ability to force the blocks down onto the flat surface? It's going to. Shoveling snow, pushing snow proves it. Okay, so there can't be these glaciers that spread out all over these flat plains for hundreds and thousands of kilometers. It's impossible. It's not possible by the laws of physics that the geologists forgot to check about. Okay, so it just is not possible. Okay, and as far as where could all this debris coming from somewhere else, okay, there's somewhere else on the earth. Well, this is what Velikovsky was talking about, okay, in Worlds in Collision, all right, and that the whole entire earth, as they find out when they do all these satellite imaging or whatever it is, the earth has evidence on it like the moon, okay, of all these craters all over the place. And the first thing that comes to people's minds, of course, is impact craters, but there's also a different kind of crater that you've never maybe even heard about, okay, that impact craters versus electrical discharge craters, okay. Plasma craters from experiments match real craters, okay? They can do because electricity is scalable, all right, from the macro to the micro, because it's a physical experiment that anybody can do, all right? So craters are electric, okay? Just the way that they form is impossible that if they were forming from impacts in many instances, all right? But something's going on, okay, that's throwing debris places, etc., from one place hundreds of miles to another place, and in more violent activity like that of the Grand Canyon, for example, okay, it was a giant Lichtenberg figure, and by the lake that's above Göbekli Tepe, okay, giant Lichtenberg figure, okay, something like that, in a scar on Mars, which seems to be a Lichtenberg figure. All right, this giant arcing that might have taken place when the planets rearranged themselves like billiard balls and all arced onto each other, and that's why they find, Mars meteorites landing on Earth because of the debris of something that might have hit Mars and caused this scar. Well, the Thunderbolts Project says it was electrical scarring. That's what their whole shtick is all about. Okay, electrical geology. Okay, and Andy Hall goes over it. Okay, just some brilliant things are said about it. Okay, lightning scar Mars, keystone pattern that happens. It's obviously not an impact crater. Okay, many craters that they say are impact craters are not. They're electrically formed. Alright, so in any case, this is where a lot of debris can come from one place or another. The whole Earth is pockmarked with these lakes on the eastern part of the United States, which have these perfectly round patterns and look like chain, meteoric chain impacts, similar to that, but chain impacts can be caused by electrical discharge as well, which the thunderbolt totally is for. Okay, this is what Velikovsky said. You can find all this stone around the planet from these cataclysms that happened in the past. Okay, and there's questions about these things. So, like Corliss goes over in his books. Okay, and again, go see Harry Hubbard's video here about it, and he'll tell you all about what Corliss says about it. That doesn't make sense, that are anomalous, that can't possibly conform to the theory of the Ice Age and these glacial erratics, okay? And I'm saying, okay, here's my position on it, all right, that these glacial erratics could have been not glacial erratics, but could have been moved by people. All right. When you see these giant cyclopean megaliths, like the one in China, like the ones in Baalbek and everything, why couldn't it be people of these ancient times be putting these things here? Okay. It almost looks like this one. Seems like obvious that this is one of these tests of strength that these people were known for, doing things. There's all these tilting rocks and perched rocks and perched stones and perched boulders and all these sorts of things. There's the whole entire United States and northern part of America is filled with all these native stonework, just everywhere. I'm reading this book, The Shadow Under the Rock, by Peter Waxman, the one that I'm mentioning right now. And it's just like stonework in the northeastern part of the United States here. Just you walk into the forest anywhere, and it's there. Okay. They're saying, no, these things, they could have been done by people, couldn't be moved. Well, if you look at all the cyclopean and megalithic stones moved around, that we know people moved around, why couldn't have been people be doing it much earlier in time? And that's what's responsible for these things. And other causes, okay? Some of them are attributing to, what Velikovsky is saying is these cataclysms happening in the past and these huge earth changes going on, and that Randall Carlson talks about, as well as so many other people. All right, and they know at certain intervals that these things happened. All right, through ice core, core samples and whatnot. So look, whereas some of these things could be natural, others can be totally man-made and man-manipulated. And I firmly believe that. Okay? Just like this one right here. Alright? Don't believe it. This one right here is one of those. Despite what geologists say. Okay? Geologists like Robert Thorson, he'll tell you all about it, how it's a glacial erratic, okay? And this guy said to me on Facebook, that, he was starting to, he's starting to cause him low IQ, okay, And I responded to him, he said, that's because you're reacting like that is because you're brainwashed into believing this theory that doesn't wash. And people disagree with it on good grounds if you care to hear about it. But you see, you're never going to hear about it because you have to read Velikovsky and Corliss. And again, Corliss writing these things for the government, educational books, he would have to understand these particular subjects intimately. Okay, so he's not a dummy. Alright? At least the government didn't think so. Alright, so this whole thing where these things are deposited nice and comfy, on the ground there, without drag marks and channels cut in as it gradually receded, well, I'm sorry, that doesn't make any sense. They're trying to give you the impression that they were just floated right down into the position that they're at from above. Alright, so I'm having problems with that. And the same problems that people have with these cyclopean cut blocks of stone from around the earth, like at Baalbek and whatever, being moved by people who are basically almost cavemen. Alright? But they did, didn't they? Right? So, in any case, guys, forget about this fiction about glacial erratics. Alright? This is probably not a glacial erratic. All these things, half of them or most of them probably aren't, all put there by people for reasons. And people look, those ones even look similar to each other, by water, no less. Isn't that curious? So, look, these people worship stone. We know all about it. These pages are dedicated to it, like all of these ones are dedicated to it, about how people in the ancient past worshipped stone, built with stone, did these amazing things like this. Alright? So, in my mind, it's more highly probable that these things are the result of that and have nothing to do with glaciers if you believe the Ice Age theory. Okay? Which I give my own reasons why it's impossible. You could do the experiment yourself. Next time it snows, heavy snow, go out with your push shovel and just start pushing. Okay? 12 inches of wet snow before you get stopped. Use all your strength and might to do it. And I bet you that thing stops you dead stop. All that weight in front of you. Can't push anymore. Big? Alright. Anyway, guys. Hope you enjoyed that. Sorry it's so long, but you gotta go through these things, okay? I could just tell you in 10 minutes what I think. Alright? Or a couple of little factoids or whatever it is. Do you have a full understanding of things after that? I never do. So, in any case, guys, hope you enjoyed that. It's some fun poked at this nonsense here. I'm sorry, but the whole Ice Age and Glacial Erratics are a bunch of nonsense. Okay, first you have to believe in the Ice Age and glaciers pushed out billions and zillions and trillions of tons of material in front of them over flat surfaces, while gravity affected it on whatever slope that was. It could only be a couple of miles high depending on where you are, or less. Alright, gravity was doing all that stuff, right? Didn't I just show you that? Low glaciers. Okay. Force of gravity. See? Alright. It's not that strong. It's the weakest force in the universe. Electromagnetism is the strongest force. Alright, guys, anyway, Buckcat 7 signing out. Peace.